Previously on Science Time. Now in this box is something called a perpetual motion machine.
You are accused of breaking the laws of physics.
What is the point, Your Honor?
That's it. Invalid argument. I sentence you to 1 week in jail.
Well, that wasn't a fun week. Prison's no joke. You get locked up with some serious criminals. My cellmate got locked up for speeding, and not just any type of speeding. He exceeded the speed of light. Sorry to be rude. Just 1 second. I have to call my bro. He's supposed to be picking me up today. Just 1 second. Huh? Yo, what's up? Where are you? You're supposed to pick me up, remember? Yeah, sorry about that, bro. I got caught up in a bunch of business meetings right now, so I can't make it. But I did get that magnifier thinger for you.
Remember, proper handling of a microscope is important. Always carry with both hands. Grasp the arm with one hand and place the other hand under the base.
Okay, fine. I'll just walk back to the classroom. But yes, that's not a thinger. It's a compound microscope. A compound microscope? Well, a microscope is a tool or instrument used by scientists to effectively observe things that are normally either hard or impossible to see with the naked eye.
Yeah, I didn't quite get that. It's really hard to hear.
Technically speaking, anything that magnifies an object, meaning it makes it seem larger than it actually is considered a microscope. Just simpler. In fact, a basic magnifying glass that you might have had is actually classified as a microscope.
Yeah, bro, I didn't.
A compound microscope usually refers to a tool or instrument used by scientists to effectively observe things that are normally either very hard or impossible to see with the naked eye. But technically, you don't have to be as complicated as that. Technically speaking, a basic magnifying glass is classified as a simple microscope.
Yeah, dude, I'm still having trouble
But the
hearing
microscope I'm getting is what is called a compound microscope. These microscopes actually come in 2 types. One is for dissecting, and one is for research. The one I'm getting is a research microscope. Both microscopes have a few differences, but we'll get back to that when I get back to the classroom.
Yeah, okay, I'm just gonna hang up now. I'll get...
Oh, that was such a long walk. Man, Eastern Canada is far away from where I am. Can't imagine anyone making that truck over. Anyway, today we're going to be looking at not this because we're in biology now. And now biology is the study of living things. So the first thing we need to do is talk about microscopes because that's how we observe these little things. Scientists use microscopes to look at microorganisms and things that we wouldn't be able to see with our naked eye. Compound microscopes are the things that scientists actually use a lot. There's 2 types. There's dissecting and then there's compound. Okay, I'm sorry. I'm getting distracted here. I have to open up that box. If it's a perpetual motion machine like it said, man, it's going to change the world. I can't imagine something cooler than that being in this box. All right. Okay, here we go. Let's see this. This isn't a perpetual motion machine at all. It's some sort of gizmo. Why do we need such a big box? I should have felt how light it is. Oh. Well, sorry guys, I kind of got ripped off here. Press here to downsize. Oh, maybe it's like a budgeting machine or computer, something like that, to help you with finances. Anyway, let's try it. Ah! Well, this for sure breaks the laws of physics. This is insane. In fact, it doesn't even make sense. If my molecular structure is intact, which it looks like it is, then my mass is approximately the same. But since I'm the size of a breadcrumb right now, all that mass is compressed, making me super dense, even denser than my brothers. If this was reality and not some YouTube video, then I most likely would fall through this desk the way a hot knife cuts through butter. Hey, mister, what's up? I got your microscope for you. Where are you? Mister? Hey, down here. It's me. It's me. Don't you see me waving my arms? Hey, bro, I'm right here. Come on. Inconsiderate guy, how could he even do that? Plug in the microscope, you dinkle dork. Hey, mister, is that you? Yes, for some reason the gods of entertainment thought it would be funny if I shrunk down to the size of a breadcrumb. Man, mister, I'd love to help. You know you're my brother. But I don't know anything about microscopes. The only scopes I know of are 360 no scopes. Come on, use the microscope. Just plug it in. Right, okay, yep. That should do it. Okay. So, how does everything work? Well, first off, right here on the back of the microscope is a power switch. This allows the microscope to draw electricity from the outlet. This powers the microscope's light. And since this particular microscope is a research microscope, we only have one single light. And remember what I was trying to say before? There are two types of microscopes. Well, two types of compound microscopes. A dissecting one and a research one. The dissecting one has two lights. But we'll get into more detail on dissecting microscopes on another time. Oh, I see. The light's under this thingy. This thingy that you're referring to is called the stage. So like a stage on Broadway, right? Yes, it is pretty similar. This is the main platform where we present what we're trying to look at. I guess similar to a theater stage. Except the specimens are the actors in this case. Oh, that's neat. But you're so small, I can't see you. I can hear you a little bit, but I can't see you. Well, you silly goose, that's why we have lenses. Here, go ahead and put your eye on that ocular lens. The what? So the lens you look through directly with your eye is called the ocular lens. And this actually magnifies the image by 10 times. I can't see anything, it's just all white. Good, okay. So right under that ocular lens is something called a revolving nose piece. This part rotates, allowing you to switch between the objective lenses. Oh, okay, makes sense. It's like changing the weight on the leg press at the gym. The objective lenses are the additional lenses you look through after the ocular lens to magnify the image even more. In the case of this research microscope, there are 3 different objective lenses. There's the low power one, which magnifies the image 4 times. There's the medium power one, which magnifies the image 10 times. And the high power one, which magnifies the image 40 times. Okay, the image is still blurry. Blurriness isn't a problem. The microscope actually has 2 knobs that help you adjust focus. What I just landed on is called the coarse adjustment knob. What this does is that it moves the stage up and down so our focus changes, so we can see things more clear. But this makes big changes at a time, so it really only is used on low power. And this right here is what's called a fine adjustment knob. This makes very small changes of focus, so you can really hone in on those small details. It doesn't make sense to use this when you're trying to make huge focus changes, but when you're trying to get that little bit more detail out, this is the thing you use. Yo, I think I get it. Hop back on the stage so I can focus on you. Hey, I can see you. Wait, what? Wait a minute. Okay, well see, research microscopes like this actually make the image you see look upside down and backwards compared to its original orientation. So make sure you position your specimen so you can compensate for this. In fact, my apologies. There we go. Oh, this is frustrating. Why can't it just work? Hey, now it could be worse. So in reality, if this wasn't a YouTube skit, you wouldn't be able to see me at all. It would look like this. What? Research microscopes use transmitted light for their image. Basically, it's a white light that only comes in one direction, below the stage, making anything not transparent be covered in shadow and be a silhouette. This makes them useful for looking at cells and bacteria and other transparent specimens, but not complex organisms like myself. Sounds legit. But for the sake of fun, let's pretend you can see me through this research microscope. Now, if you wanted to see non-transparent specimens in real life, you need a dissecting microscope, which uses incident light, which is light that is reflected off the specimen from the microscope's second light source. A dissecting microscope has 2 light sources, remember, one on the top and one on the bottom. In terms of the image produced by a dissecting microscope, the image created actually wouldn't be inverted like a research one. We would refer to this as a virtual image. Wow, this is like so rad. You look like 1,000 times bigger right now. Well, it's actually not 1,000 times larger. Actually, at your current magnification, I would only look about 40 times larger. What? How do you figure that? Well, basically, you can figure out the total image magnification by multiplying the ocular lens magnification, which is 10, by your current objective lens, which is either 4, 10, or 40 times. In this case, we are using the 4 times objective lens because I'm not that small. So our current magnification is simply 10 times 4, giving us a magnification of 40 times. Try flipping that revolving nose piece so we can use the 10 times objective lens instead of the 4 times objective lens. This magnification is 10 times 10, making our total magnification 100. But this is a little creepy. Let's switch it back for now. I don't like you this close. Hey, wow, that's actually easy. I do more complex math at the gym. It is, isn't it? Just remember that as you increase magnification, you are zooming in more and more, making the overall field of view smaller as the magnification increases. Dang it, I thought this was going to be easy. Don't worry. We'll walk through it together, alright, bro? The unit we use to measure field of view is microns. And 1,000 microns is equal to 1 millimeter. How crazy small is that?
That's crazy!
The field of view on the lowest power is 4,000 microns wide. On medium power, the field of view is 1,500 microns. And on high power, it's only 400 microns wide. Oh, okay. So what can we do to estimate the size of a specimen? Well, let's imagine we duplicate me until I fill up the field of view. So let's go through this right now. Imagine that there's 3 more of me. Hey, what are you doing? No, get back here. Come on, guys, we need to focus. Come on, be organized. So if we know the field of view, meaning how wide it is, we can use it to estimate how big the specimen we're looking at is. All we have to do is see how many of that specimen can fit in that field of view. Wait, so that'd be 4,000 divided by 4, giving us 1,000 microns. Exactly, and if my widest point is 500 millimeters when I am normal size, how much did I shrink? Well, first, you'd have to convert 500 millimeters to microns. And if 1 millimeter is 1,000 microns, then you'd multiply 500 by 1,000, making your normal width 500,000 microns in length. Yes, keep going. So after that, if you wanted to figure out how much bigger you are when you're normally sized compared to your shrunken size, you divide your normal size in microns, in this case 500,000 microns, and then divide it by the size of your shrunken self, which is 1,000 microns. So you're 500 times larger in normal life than you are in your shrunken state. Good job, bro. I'm impressed. And remember, this example is the exact same as if you drew a drawing of your observation and wanted to see how much bigger your drawing was compared to the actual specimen. This is sweet, dude. I'm so pumped. I actually learned something new. Oh, by the way, I found this on the ground. No, don't press that button. Oh, come on, mister. Do I look silly enough to press a button on a machine that's function is completely unknown to me? That is the device that shrunk me. What does it say? Anything on how to get me back to normal size? Unfortunately, it says irreversible. No upsizing. Man, I think you're stuck like that, dude. There must be something we can do. Some creative idea so we can get back to normal. Don't worry, I have an idea. Well, that was a crazy last few lessons. Me going to court, then jail, then shrinking down. But regardless of all the silliness, I think we did learn a little bit. Anyway, I'm glad to be back to normal. I'll see you guys next week. See ya. Okay, time to prep for next week.